Hi, I'm Ryan Weeks. I'm with Ophir Spiricon. Today we're going to be talking about Ultracal and what a difference it can make in actual beam profiling measurements. The performance of today's laser systems can be strongly affected by changes in beam diameter. Ultracal helps camera-based profilers accurately measure beam diameter for optimal performance. BeamGage uses our patented Ultracal algorithm to properly set the data baseline or zero reference point to as accurate as 1/8 of a digital count on a pixel-by-pixel basis. Ultracal helped establish the ISO 11146-3 standard for beam measurement accuracy. Making a beam diameter measurement is a lot like measuring a cotton ball. There is no hard edge to reference. Ultracal enables BeamGage to find the true beam diameter of the laser beam. BeamGage includes BeamMaker, a synthetic laser beam generator that allows us to use the software as if we were measuring an actual laser. We will configure BeamMaker to generate a 2mm beam. The green aperture shows where BeamGage is calculating the width of our beam, 5.27mm and 4.09mm. The BeamGage 2D display shows the actual beam width is much smaller. This measurement error is caused by noise in the system. Let's see how Ultracal improves our beam width calculation. We start by clicking the Ultracal button. BeamMaker blocks our beam, then collects sample data and calculates the baseline with the noise removed from each pixel. BeamGage now calculates the accurate beam width without system noise. When we talk about noise, we're talking about electronic noise and optical noise. Think of old-time television. If you turn on your TV and select a station that is not being broadcast, you see noise. Similarly, cameras also produce background noise, as well as picking up ambient information from overhead lights, sunlight, or even a back reflection from an optic. Let's examine background noise from 1 pixel before Ultracal. This graph shows the values from 64 frames. Some counts are higher than others. Ultracal calculates the average of these counts and sets a true baseline. When the laser stimulates this pixel, BeamGage will remove the average noise from the measured signal. Applying the Ultracal correction to all pixels in the camera results in the most accurate beam width measurements in the industry. The measured beam width is now accurate to 3 decimal points at 2.002mm and 1.999mm. Without Ultracal, the sum of the noise from each of the millions of pixels in the camera is added to the beam width measurement, causing significant error. If you have any questions about Ultracal, BeamGage, BeamMaker, or laser measurement in general, please contact us at 866-755-5499 or visit us on the web at ophiropt.com/photonics.